and we'll get started here.
All right.
Okay, so the function I'm sharing here is 4 minus 3x. And let's just start with a table. So you're going to be asked to find x, f of x, and unless otherwise, we'll just always start with this set, -2, -1, 0, 1, and 2.
All right.
Right. And that doesn't matter what order you do this in. You can do the positive ones first, or the negative ones first, or 0 first. It doesn't really matter. How comfortable are you coming up with these values here? Can you do this on your own here in 60 seconds?
Yeah, I could do it in probably like more like 2 minutes, but I can.
Okay, we'll take 2 minutes here and see if you can work these out, and then I'll put the correct answers here. You're just substituting these numbers into the equation here.
All right, sounds good. I actually have a question for the first one. So would it be 4 plus 2/3, or would it be like 4 times +6?
So the first thing I would write is 4 minus 3 times -2 in parentheses.
All right, yeah, that's what I have.
And then the negatives cancel, so it becomes 4 plus 6, which is 10.
10, okay. All right, thanks. There's like another one where it's like the format's kind of like what I was saying the other way, where it's like if there's a negative, it has to become a fraction.
We'll get to that. Yeah, we'll build up to that. We don't want to jump right to that.
Okay, all right. I'll go finish the rest of it now. All right, I got it all down.
All right, so you should have gotten 10, 7, 4, 1, -2. Did you get that?
That's what I got.
Now, if you're wondering how I did that so quickly, the slope is -3. So these have to go down by -3 each time.
Oh, yeah.
Okay. All right. So now what is the ordered pair?
-2 and 10, -1 and 7, 0 and 4, 1 and 1, and 2 and -2.
Good. Okay. So now there's a bunch of things that that you could do here. The first one is to graph these. This one, I guess I'll throw in a graph, but if you really, this one probably should I kind of recall you get one of these linear ones to start. So you need to show enough data points. Basically, you need to show all these points on your graph so that your instructor believes that you know how to graph it.
All right. So you should make like a graph where it's like 10 on the x-axis and 10 on the y-axis.
Let me help here. So I'm gonna label the points here for you so you can see this. I don't know how many they want. It seems like that they could. The truth is you only need 2 points for a line, but we'll assume they want all of them.
All right.
And then let me snip this in here because we'll use this graph when we're done. So sometimes they give you a graph, sometimes they don't. I don't know. Did the instructor say to bring a ruler to class?
My instructor does not say bring a ruler.
Okay. Well, here's your graph. Okay. And then you want to put arrows at the end. That would be a mistake.
Keep going.
Yes, it keeps going. So arrows, that's important. All right, so there's a lot of things we can talk about here based on the stuff you did in class here. So let's start with the y-intercept.
That would be 0 and 4, right?
0, 4, and this is where it crosses the y-axis. And it is not to be confused with the x-intercept. I know in the example that you sent a picture of, there actually is none, but here it's where it crosses the x-axis. So this one's a little bit different. This one, you have to set y equal to 0. Okay, so we had y equals 4 minus 3x. So we're putting, so it would be 0 equals 4 minus 3x. And now you're solving for x. Hopefully that's not too unfamiliar, something you've seen before.
All right. Wait, so set y equals 0 then. That's for the x.
That's for the x-intercept, yeah.
So,
Is this something you have not seen?
Not really.
Okay. Are you comfortable solving this for x?
I
It's
just
okay
have,
to say no.
I guess you have to get the x by itself, right?
Yeah, so you would add 3x to both sides.
So then 3x equals 4, and then over 3, 1 and a third.
Yeah, so the point would be 4/3, 0 for that.
4/3, 0. Okay, and it's
We'll do more.
Get it on the graph, like
it's that point right there, but you don't know exactly what it is until you solve for it. You have to be able to be comfortable doing that.
Okay.
Okay, so
to practice it.
Okay, so your domain is this, and I think we talked about this idea that you don't really need to know what this is, you just need to know how to write it. This means everything is, all real numbers, everything is good.
Mm-hmm.
The range is different. It's y this time. And it's also all real numbers. And then here's why. It goes up forever, it goes down forever, it goes left forever, it goes right forever. And that's why this is okay.
Oh, real numbers. Okay. So I know she does something for, I think, like the range, where it's like the number, like one number is bigger than the other or something.
Yeah, we'll get to that. But do you see how the y values go down forever and the x values and they,
it's just like an infinite line.
Yes, there's nothing. So this one's one of the nice ones. Okay, so let's go back to our original function here. Original function here was 4 minus 3x. And I want you to find the rate of change, which is also called the slope, from or between x equals 0 to x equals 2. And basically what I'm asking for is for two ordered pairs here. And you already have them from the table.
So 4 and -2.
You've got these two ordered pairs. You've got 0, 0, 4, and then 2, -2. Okay, and that comes from putting 0 into there and 2 into the equation. So the slope formula is, do you remember from class?
y2 minus y1, x2 minus x1.
So this is your x1 and this is your y1. This is your x2 and this is your y2.
Okay, and then then it would be -2 minus 4 and 2 minus 0.
Okay, so that becomes
6/2, which equals 3.
-3.
Oh, -3.
And notice that's the same as this value here. It's the same.
Right. Okay, so then how would I know that I have to put the 0, 4, and the 2 and -2? Like, how would I choose those two out of like the 6?
They tell you when x is 0 and x is 2. So they tell you x is 0, so you find the y value.
Okay, so like if it was, let's say it's a completely different thing. So if there's one that's like 0 and 50, like 0 comma 50, and then like x equals 2 would be like 2 comma 1,000. It would still like be put in that way.
Yes.
Oh, so it's like, okay, I think I get this now. So there's like, it's -2, -1, 0, 1, 2. It tells you which one of those 6 you need by saying the first part. So like, for example,
Yes,
0.
exactly. Yeah.
Okay, I think okay, that
Mhm.
makes a lot more
Yep.
sense. And then you just have to do the slope formula.
Yes.
And then that would be your range, correct?
It's just your slope.
Okay.
It's your rate of change. The rate of change and slope are exactly the same.
Rate of change. All right.
Like
I'm
I could
writing
ask
up
you
the
how.
stuff this time. Rate of change and slope are the same thing.
Yes. Yes.
All right. Sorry for cutting you off. What were you saying?
Well, I was just going to give you an example of how sometimes you can be asked the same, for the same thing 2 different ways, but that doesn't really matter here. So let's do one more of these, but let's do it much faster here. Let's say y equals 3 minus x over 2.
All right, and then that
Okay.
would be -2, -1, 0, 1, 2.
Yeah, we'll do a table here together. -2, -1, 0, 1, and 2. All right, so first one you're going to do is 3 minus -2 all over 2. So do you know that you have to do the top first?
Yeah, I guess I'd probably do the top first naturally.
Yeah, and you have to. So this becomes 5 halves.
5 halves.
Yeah. Okay.
Plus 2 over 2 equals 5 halves. And then I would not write it out as 2 and 1/2.
No, you either would keep it improper or a decimal. Probably improper is better for you at this point, which is a change from what you've been doing in the past.
Okay.
So for the next one, and this is very important, notice that when I substitute a variable in for x, especially when there's a subtraction symbol in front of it, I put it in parentheses. This -1 is in parentheses. This becomes 3 plus 1 over 2, which is
2.
2. Okay, so see if you can do the rest, please.
All right. Okay, I think I got it all.
All right, so the next one is 3 halves, then 1, then 1/2. Is that what you got? Say that again.
I think for it, it's like whenever it's would be like 2 1/2 or like 2 1/3 or something like that. Just always keep it as the
Yeah, it's okay to keep a bigger number on top, even though you've been told like, no, you can't do that. Like you actually can.
Okay, all right. I'll start doing that for this.
But did you get these numbers?
Yes, I did get those numbers.
Okay, so this graph, and we don't really care what it looks like exactly, but it does one of these again. Okay, roughly. Make sure you get your.
Called again.
Say that again.
What's that straight line called again?
Which straight line? The horizontal one?
Or in the graph. Like what would that graph be called?
It's just a line.
So just a line graph?
Yes.
All right.
Okay. So let's do this again here. The y-intercept, okay, is what? And you can get that from the table here. It's
the y-intercept is 2. Yeah.
this one right here.
Oh, right, 0, 3/2, zero's on the one.
Yes. So the y-intercept always takes on the form 0, comma number.
All right. Y-intercept always has 0, comma.
And this is the problem here. The challenge is that the x-intercept takes on the similar form, but different is
It's just like
number comma 0, and it's very easy to get them mixed up.
all right, so it's like y is going up, x is going to the side.
Yes. So we also said the x-intercept is where y equals 0. So if we go back to our original like thing that I gave you, which I'll copy down, y is now 0. And I need you to solve for x.
Solve for x, okay.
Any idea how to do this?
I guess you'd have to find what the x-axis is, I guess. So
there's a set of steps here. Like in the previous problem, let me scroll up. In the previous problem, we just moved the x over to the other side, right? That was right here. Do you see that?
yeah.
We moved x over. The problem is we can't do that here because x is it's being divided by 2. So how do you undo division by 2?
Put 2 on the top.
Multiply by 2. Yeah.
Oh, well, yeah.
So what's 2 times 0?
0.
Okay. So now how do you move x to the other side of the equation?
Would you make x2? Oh,
You
you'd
just add x.
Oh, okay. X equals 3.
Now this is beyond what you're doing right now in this class, but it seems like this school district tends to do these things where they kind of push you in that direction, like, oh, you should know that kind of
So
thing.
it'll be like in my near future.
Yeah, and they might even ask on this test tomorrow, so that's why I'm trying to show you a few examples of this.
Okay, that makes sense.
All right, so now let's find the rate of change, which means slope from, and let's go x equals 0 to x equals 2. Okay, which means you need 2 ordered pairs. You need 2 ordered pairs. And if you scroll up to our table here, I'm asking for these 2 ordered pairs, 0, comma, 3/2, and then 2, comma, 1/2.
So then,
Get this in our workspace here. Okay, so the slope
oh, right,
formula is,
y2 minus y1 over x2 minus x1.
yes.
So then 1/2 minus 3/2 over 2 minus 0
Good. And
equals negative 2.5.
what is, so how do you do this up top? They've got the same bottom. So what do you do to the top numbers?
Subtract them.
Okay, so what is 1 minus 3?
Negative 2
So you have negative 2 over 2.
over 2. So then negative 1 over 2.
Yes.
Okay.
Great.
Negative 1/2.
Okay, now really quickly here, the domain and the range, they're this again. And the thing that I need you to remember that's really important here is that when you have a line like this one, your domain and range are always this. When you have a line, as long as it's going like up and to the right or down and to the right, it's always this. Like there's no exceptions to it.
Okay, so it always goes up like that. It's always a straight line.
Yeah, but there are exceptions to this, but as long as you have a line that goes up and to the right or down and to the right, this is what you're looking for.
Okay. All right.
Okay, so now we should
it'll just be straight lines.
well, it's kind of not trying to be critical of you, but a line is always straight, so it's unnecessary to say straight line. And maybe that's language you're using. Like what I'm trying to tell you is that the exceptions, let me draw the exceptions here. Maybe you've already seen these in class. The exceptions are a vertical line,
Mhm.
which is like this, and a horizontal line, which is like this.
What's the like one where it's shaped like a V or like an N kind of? What would that be called?
The V is an absolute value.
Absolute value. Okay.
Yeah,
I don't know why I feel like this just is like connected to the absolute value. For
it
some
is, believe it or
Okay.
not. Okay. But what's got to be really clear is that if I give you an equation of a line, which is what we did, our first two examples were equations of a line.
Oh, hello.
Yeah,
Okay.
since these are equations of a line, they're always this, like this.
All right. I actually can't see it right now.
That's interesting. Are you in the Zoom window?
Yeah, I'm like, or here, let me see if I can like, yeah, I can't see it right now. I even made like it full screen.
All right, let me stop sharing and then I'll share again.
All right.
Okay, it shows I'm sharing.
It shows our slope for this, and then our dr that's circled, and then the
Yeah, exactly. Yeah, that's what I'm trying to say. That for the first two examples, the domain and range is always like this.
oh, okay. I thought you were like drawing something, and I
No. Okay, so we're gonna go right up to 6. I got to make sure we get in 2 examples of the exponentials. So let's do f of x equals 2 to the x plus 3.
plus
Okay,
3.
so these are different. This is x is an exponent, and these are different. So these are like the ones you did in class today, and you're going to make a table. So you have x, and we'll just do these one at a time. Okay, we'll do them together here.
All right.
-2.
So 2, -2
2 to the -2 plus 3. And
equals
this,
positive. So would this be 1/4?
yes,
Okay.
plus 3. So
So the way
it's
like
one.
I was taught it, like should I have a different thinking process to solving this? So the way I was taught it is I look at it so it becomes -4, and then you can't have it be a negative. So then you have to put the 1 over whatever that number is and then get rid of the negative. Is that like a good way to think about it? Or
It's okay for right now.
all right.
We'll adjust your thinking, in a month or two whenever you get to this topic again.
All right, man. I
So
can't believe this stuff keeps going. I feel like it just ends right here.
yeah, so that's 3 1/4, and then let's write the ordered pair next to it.
Ordered pair. So -2, comma 3 1/4.
Yes.
So then I guess for the
So now for
next
-1, and your approach here,
would become 1/2 plus
yeah,
3 equals 3 1/2. And then -1, 3 1/2.
okay.
And then so for 0, like 0 always becomes 1.
Anything to the 0 power is 1.
Okay, so then would it just be like 1 plus 3?
Yes.
Okay. Wait, I forgot if you like I know I've meant like asked this before, but is it possible for the 0, why is it like become 1 like that, or is it just like one of those things where it's like that's just the way it is and it
Yeah,
doesn't?
it's a definition. When you get into the why, like that's a different classroom down the hall, kind of,
Mhm.
we're teaching you like what to do, how to do it. The why, that's like I don't know. It's like there's books on why, why are we here?
Yeah. It's like what's our purpose of life?
Yeah, exactly. And I'm not trying to trivialize what you said. It is important. Just you're gonna have to
It's
accept
just
it.
the way it is.
We're gonna accept it for right now because the goal is to do well on this test, please your parents, please yourself. You've got other things you like to do. That's
Mhm.
why we're trying to get through this. And it's more important to do that than to break down why something is the way it is at the moment. Okay, so 2 squared plus 3, that's 4 plus 3, that's 7. All right. Do you have any graph paper?
Yes. Oh, right. From last week you mentioned get it. Yeah, it's just in my table on the other room. Do you want me to go grab that?
Well, no, you don't need to because we're kind of short on time today, but I'm going to graph this. But what's really important is you have to, with these exponentials, you have to be really, really careful with how you graph them. Meaning like
Mhm.
you need to do a really good job of graphing them. Otherwise,
It
you
can all
just,
look messed up.
it's really unclear. So hopefully your instructor will give you nice graphs. They generally don't. Sorry. So first point is I'm going to graph from the bottom here 2, 7. So 2, 1, 2, 3, 4, 5, 6, 7. 1, 5, 1, 2, 3, 4, 5. What do we got next? 0, 4.
0, 4.
And then this is where it gets a little, a little dicey. So it's -1, 3.5. And then it was -2, 3.25. Now, this is way beyond the scope of your class, but you're supposed to know that when you graph something like this number right here
Mhm.
is the horizontal asymptote.
Okay, so then if
So
I
you
was
actually,
asked like what the xanatote, is that how you say it?
asymptote, yeah.
Asymptote.
Yeah,
So if
asymptote.
that was like on the question, so it's like say the x value, say the y value, say the domain, say the range, say that, and like axis symmetry. So I'd write like 3. Oh, it has to be one under the final dot, right? She was like just started talking about this today.
It's a bit there's so much that goes into this. What I need you to see is that it approaches but never touches this. So
Mhm.
like if we were to put in -3, you would get a number there and that, like you just they just keep approaching it. So the graph, when you connect these, it's like an airplane landing kind of. I
Mhm.
mean, airplanes don't come in like that, but like
Yeah. Let's say it's a
it softens. Yeah. So you have to get this picture. So if your here's what your instructor is looking for. If you cross this line, they mark you off. It does not cross this line.
so it has to be like below. So let's say if that number instead of being like what is it, a third or like 2 1/3 or 2 1/4.
Well,
But if
it would be, it's going to always be 3 and something, 3 and a fourth, or 3 and an
Mhm.
eighth, 3 and a 16th, and so on.
Well, also the what's it called? Uh, Asymptote.
Asymptote.
Asymptote. So it's always 3.
Well, it's always this other number,
Okay. Always the other number.
that other number, the
Uh,
number without the X.
number without the X. Okay. Number
Okay,
without.
and it's like if you're worried about how to say it, it's that word M and then like tote, like you've got a asymptote.
All right. I think
There's a
okay.
P2 asymp. I mean, if but it's, you say it so quickly. That's how you pronounce it, asymptote.
Asymptote. All right.
Yes.
Asymptote. All right.
Yeah. Okay. So the key here is like you can't cross this line when you're graphing. You need to show all these points. It's not a straight line. It's got a curve to it.
You really have to show that it's not like the dot wouldn't be on the asymptote.
That's right.
All right. I'll keep that noted because I know that's gonna be on the test tomorrow.
Yeah. Well, I'm
Yeah,
trying to warn
there's
you here. You
one
got to
thing I
put
don't really like too much about this math teacher sometimes is like the day before a quiz, she'll assign us something that's gonna be on that quiz, but she doesn't really like teach it that much to us.
yes.
So it's like something I've noticed that she kind of does frequently. But like
It,
thankfully
it,
it's something like simple like this. So
it's going to continue to happen. So you should just start getting prepared for it. Just say,
yeah.
I know this is
I
going
don't
to
know. I
happen.
think if I it seems like I have most of my quizzes on Thursdays, so maybe it might be worth, like, instead of having my meetings with you on Sundays, maybe I should try and schedule it for like Tuesdays and Wednesdays. Just
Sure.
as like all works out.
Yep. Yep. Whatever you want would be fine. So let's get to some of the characteristics here. So what is the y-intercept?
The y-intercept is 0, 1.
No. So
Oh.
what you just said is it crosses right there. Is that true?
Oh no! Oh, I was looking at the asymptote instead of the actual thing. It's 1, 2, 3, 4. 0.
Right. And if you go back to your table, you'll see that as well. It's right there. 0, 0, 4. Okay. Now, looking at this graph, I'm going to ask you one question, which is what is the x-intercept? And I'm going to ask you the same question another way. Where does the graph cross the x-axis? They're the
It
same
never
question.
crosses the x.
That's the right answer. So x-intercept, none.
None. All right.
Okay. All right. Now let's do domain and range. The domain for these are called exponentials because it's 2 to an x. Just like lines, the domain is always, always, always this.
All right.
When we were doing lines, the range was always y is all real numbers. Okay.
So
Okay.
that
So
would
y,
be the like y2 minus y1.
yeah. No. The range is y, but y is an element of the real numbers, and then you have to say y is greater than
That's what I was.
some number.
Okay.
So that number is the horizontal asymptote.
So then the horizontal asymptote is 3.
3.
Right?
So we would say
In there.
y such that y is an element of the real numbers, comma, y greater than 3.
All right. What if I were just to write and like, let's say I forget the first part, but I know it would be like y is greater than 3. What would I get marked wrong if I just wrote y is greater than 3 and not have the other part in front of it?
Yes.
All right. So I guess I'll just have to study for that tonight.
Yes. I'm sorry, it's not great. If I were teaching this to you in a classroom, I would not be emphasizing this, but your teacher is, and you have to do what they want.
They're in command.
They are in command. That's right. Okay. So we got all those things in here. Making the ordered pairs, graphing it, the horizontal asymptote, the y-intercepts, x-intercept, domain range. So here's the last thing. They are going to ask you for the rate of change, the slope, and we'll do it from x equals 0 to x equals 2 again. And we need those ordered pairs.
So then y2 minus y1.
Yes, but you need those ordered pairs.
Oh, so 0. Okay, I need to scroll up.
So you have the ordered pair 0, 4,
4.
and then I think it was 2, 7.
Yeah. So then it would be m 7 minus 4 over 2 minus 0 equals 3 over 2, and then 1.5. Oh no, that one would say it's 3 over 2.
Well, that's fine. That's totally fine.
Okay, so range, you need the asymptote to find the range.
Yes.
And then the domain. Is it the domain just the formula?
It's always this. It's always this.
Okay. So I just got to remember that, and then I just basically get the domain.
Yes.
All right, and then. Okay, all right. I think I got this now. I just need to study this a bit.
Yeah. Okay. Let's do one more question here. Let's say f of x is equal to so this is what you might see. I shouldn't do this, but I will.
Okay.
because we don't have enough time, but this is what you might see. Okay. And I'm sorry, these are, but let me just work through this and then you'll have it in your notes and your screen recording, which I'll send out probably around
Okay, I'll
7.
write this right now too, and then I can do it
That's
myself.
fine. So I'm just gonna run through this, and you won't really have much time for questions, but -2. So this is 4 minus 3 to the -2 power, 4 minus 1/9. So it's 3 and 8/9. -1, 4 minus 3 to the -1 power, 4 minus 1/3. So it's 3 and 2/3.
Hmm.
0 is 4 minus 3 to the 0, 4 minus 1, which is 3. And then 1 is 4 minus 3.
And then it looks like it's, okay, yeah. So then you'd write it out as like 3 and 8, -2 and 3/8.
So this ends up being 1, and then 2 is a 4 minus 3 squared, which is 4 minus 9 is -5. Okay. So when you graph this, you have a horizontal asymptote at 4. Okay, and then we got 0, 3. So it ends up looking like this.
And the horizontal asymptote, you find that just by like, it's 4 minus 3x and you know 4.
It's that number.
Okay.
And see that number is different than that number is different than that number is different than it's the non like number with the x.
Okay. All right, yeah. Okay, I get that now. That makes sense.
Okay. So then the next thing here is that your domain is, oh, actually we did y-intercept. So your y-intercept is 0, 3. Your x-intercept, this one has one this time. So just ignore that for the moment, because you probably won't get anything like that, but let's just ignore that. Your domain is x such that x is an element of the real numbers. Your range, though, this is what's different. Y is now less than 4 because it's going this direction here.
So when it goes down on the graph, it's for the 4 is greater.
Yeah.
Okay. I'll just have to study that a bit.
Yeah. The horizontal asymptote is at y
4.
equals 4.
And then 0 and 2 for the slope.
Yeah, so the slope. So now, that's where, you got to have these points again. So let's say you got 0, 3,
and then
your point 2, -5.
So then -5 minus 3 and then 2 minus 0 equals
Exactly.
-8 over 2, which then equals -4.
Very good.
All right.
All right. So this is a good place for us to stop. Sorry I was a little rushed here at the end. I will send you the notes and the screen recording out shortly. Thanks again, and I'll see you next time.
Yeah, of course. All right. See you later.
Okay. Bye now.